Greetings to everyone here. Today we are talking about how and why spatial mining should be conducted. Spatial mining is the process of mining on celestial bodies such as asteroids, other planets, moons, etc., to obtain rare or depleted minerals, metals, and resources found on Earth. This has many advantages. Spatial mining can help get rare resources without harming or depleting the resource on Earth, allowing it to replenish itself and not die out. This can help the ecological balance stabilize itself, and these resources will be there for future generations to use. We can achieve this by creating a robot as shown here. Robots can be a feasible solution to carry out spatial mining as manned missions are not planned as of now. The features and making of this robot will now be explained by Rudra and Vishnu.
So, how does mine work? It has two major components, the satellite and the rover. The satellite takes images of the asteroid or planet, which help us identify the resources present on the celestial body. If the satellite does find mineral deposits in abundance, a rover is sent to the surface, which mines and collects samples. Let's take a look at the satellite. It consists of an EM wave emitter, satellite dish, solar panel, light emitter, and camera. The camera takes images of the target asteroid or planet and scouts for potential mining grounds. To find out how much of an element is present on an asteroid, we use the light emitter. It works on the principle of telescopic spectroscopy. Scientists on Earth build a model of the celestial body and study how the light is reflected off the surface of the asteroid. By changing the physical property of the model, for example, increasing and decreasing the relative abundances of chemical elements, we can find the model that best matches the planet's properties.
So now I'll be talking about the EM wave emitter, which works as the TCAS, also known as the Total Collision Avoidance System. This part of the rover is extremely essential as it detects any obstacles in the way of the rover. It consists mainly of three parts. The first part is the transmitter, the second part is the receiver, and the third part is the cyclotron. So, coming to the working mechanism, this device consists of three parts as mentioned before. The first part is the transmitter. This part is responsible for sending out the EM waves. The second part is the receiver. It receives the reflected electromagnetic waves after striking or reflecting from the obstacle. And the third part is the cyclotron. It's just a device that causes electrons in it to accelerate, which induces an electrical field. As we all know, when a charge moves, it creates an electric field, and a moving electric field creates a magnetic field, and so on to form an electromagnetic wave. So, now transmitting sound waves would have been a much easier process than actually doing this. But unfortunately, sound can't travel in vacuum. As we know, it needs a medium to propagate. Now I'll be talking about the equation to determine the distance between the obstacle and the rover or the satellite. This is nothing but the modified eco formula. In this case, we just have a minus d naught in the numerator as the object is in continuous motion. So the formula is the speed of the electromagnetic wave is equal to 2d minus d naught by t, where d stands for the distance between the object and the obstacle. D naught stands for the distance traveled by the rover by the time the EM wave is received by the receiver, And the third one is T, which stands for the time taken by the electromagnetic wave to be received.
Now, the solar panel and satellite dish. So, the solar panels are the main source of energy for the satellite. The satellite dish sends the data collected through the camera back to the scientists on Earth. To protect the solar panels from space debris, they are coated with a material known as wolverine. It is a strong and self healing material, and since it is transparent, it does not interrupt the functioning of the solar panel, too. This material has already been used in the Mangalyaan mission by ISRO.
We have decided to incorporate the EM wave emitter as the TCAS, or the Total Collision Avoidance System, in both the rover and the satellite. In simple words, it will act as a sensor to detect any obstacle in order to prevent wreckage of the machinery. This works on the same principle, and the same formula may be used to compute the distance between the obstacle and the satellite or rover.
Now, let's come to the components of the rover which help in carrying out its primary function, mining. So, the solar panels produce energy which they store in batteries. Asteroids have a very weak gravitational field, which makes them very fragile. So, if we use conventional methods of mining, such as drilling, the force applied could break down the asteroids. Instead, we use a beam of laser which is powered by the batteries. The laser breaks through the crust, which produces mineral rich debris. So, the robotic arms collect and store this debris.
By using the technology as was presented here, we will be able to explore and conduct spatial mining via the help of robotics.